Hello, you're welcome. All right, so let's continue from where we stop. Now we are going to be looking at another example in this video. All right, so this is example 2. Okay. Okay, so here we have another function that we are going to differentiate by the power of n. Okay, so now, so the function is y equal to x raised to the power of 3. Okay, x raised to the power of 3, the exponent of 2x. So we have to find the nth derivative of that function. All right, so let's begin. So solution. So of course, you know how this actually goes, okay? Using Leibniz theorem, okay? You know exactly how we evaluate this. All right, so just have that the same method. If you can always, remember the same method of expanding a binomial expression, okay, this is exactly what you will employ here. All right, the same method of expanding binomial expression. Okay, now look at how it goes. The derivative of x, okay, will increase. It will start from 0, then it will increase to the maximum, okay, to the maximum. Of course, it won't actually reach to the maximum before it becomes 1, because here I have s cube. Okay, so for me to reach the point where x becomes a constant, I need to differentiate x, this function of x. That should be like 3 times. If I differentiate x the first time, it's going to be 2s squared. If I differentiate it the second, if I differentiate it the first time, please pardon me, it will be 3s squared. If I differentiate it the second time, it will be 6x. If I differentiate it the third time, it will be 6. Okay, so once x actually reaches constant value, that is exactly where I will stop. All right, so as I said, the derivative of this function of x, all right, increases, okay, to a point where it becomes constant, while the derivative of the exponent of 2x actually start from the maximum derivative, which is n. All right, then of course reduces, okay, to any point where x becomes a constant value. So can we begin? All right, so I hope you're with me. Now let's begin. Okay, so we are looking at derivative of y to the degree of n. Okay, so this is how it goes. X will start from a 0 derivative, so that is s cube will start from a 0 derivative, that is derivative 0. Please bother me. So I use brackets. The bracket, the power, okay, I put it inside bracket, which indicate derivative. Okay, that so that it will you differentiate it from a normal power of a variable. All right. Okay, then what happens to the exponent of 2x? So exponent of 2x will take the maximum derivative. Okay, then we will now go to the next term. Now remember, the next term, just like in binomial expression, the coefficient is n. If you can still remember that. Okay, the coefficient, just remember your binomial expression. Okay, now the derivative of x increases by 1. So if I differentiate x one time, or better still, let me still write it. Okay, so that is derivative of s cube increases by 1. Please pardon me. Okay, so derivative of s cube increases by 1. That is why the derivative of exponent of 2x reduces by, of course, n minus 1. Okay, reduces by 1. we go again. All right, we'll do the same up to 3 times. Okay, so I'm just giving I'm not started differentiating yet. I'm just giving out writing out the formula to help you understand. Okay, so if we go again, this is going to be plus. Now the coefficient of the next term from your binomial expression, if you can still remember, that will be n into n minus 1. Okay, then of course divided by 2 factorial. You can still go back to your binomial expansion so that you will remember this. Okay, then what then happened to the to x, the derivative of x cube. Okay, derivative of x cube actually increases by 2, while the exponent of 2x derivative, okay, reduces by 2. Then I can still now do that, the last but not the least. All right, the coefficient continues, n into n minus 1. Then of course n minus 2. Okay, now don't forget that you have to divide by 3 factorial. So I don't have space. Let me write this down here. Okay, so now the derivative of x cube, okay, will increase by 3 this time around. So it will increase by 3, that is 1, 2, 3. While the exponent of 2x derivative will definitely reduce by 3. So this is just the formula that will enable us to do this. Okay, so let's perform the actual differentiation. I hope you are ready. Okay, let's go. So let's start. Okay, so let's start. So derivative of y to the degree of n is going to be equal to, you know how we do it. Okay, so the first time there won't be derivative of x cube, so I'll write it out like that, x cube. Then if I find the derivative of exponent of 2x to the degree of n, remember that we've talked about that, that's going to be 2 raised to the power of n, then exponent of 2x. Okay, then plus. The next time the coefficient is n, okay, we'll write the n. All right, then we differentiate. We find the derivative of x, the first derivative of x. If you differentiate x cube the first time, we are going to have 3x squared. So let me put dot to represent multiplication, 3x squared. Okay. Then of course, if we differentiate exponent to x, okay, we differentiate exponent to x. The derivative of exponent to x reduces by, okay, by n minus 1. So to find that derivative, remember how it is, okay, how it's going to be. That's 2 raised to power n minus 1, then exponent of 2x. I hope you are with me. All right, so let's proceed to the next term. Then the next term, you know the coefficient, that's going to be n into n minus 1. Okay, then of course divided by 2 factorial. Divided by 2 factorial. Okay, so now this time around the derivative, I will have to find the derivative of s again. That is this time around, that's the second derivative, right? So if I differentiate the last derivative, I will end up having 6x. And of course, if I reduce the derivative of exponent of 2x to n minus 2, you know what is going to be. That's going to be 2 raised to the power of n minus 2. Okay, then of course, exponent of 2x. I hope you are with me. Okay, So I think this is the last stage. This definitely will be the last stage. The last stage, you know what our coefficient will be? That is n into n minus 1. Then, of course, n minus 2. Now, don't forget to divide by 3 factorial. Okay, so now finally we can now find the last derivative of x, which of course, if we differentiate 6x, we have 6. So that's going to be dot 6. Okay, since I don't have space, let me write this one here. Dot. But if you have space, you can actually continue, okay? So then, of course, the derivative of exponent of 2x to the degree of n minus 3. Yes, to the degree of n minus 3. That's going to be 2 raised to the power of n minus 3, then exponent of 2x. All right, so we are done, almost done. So just for us to simplify. Okay, so how do we simplify? So the only way to simplify now is I will definitely take out the common factor. 2 raised to the power n is a common factor. Exponent 2s is a common factor because it is found. 2 raised to the power n is found here. 2 raised to the power n is also found here, and exponent 2s is so. 2 raised to the power n and exponent 2s is found everywhere. So I can take it out as a common factor. All right. So let's take it out. So here we have the derivative y to the degree n is going to be equal to, okay, so let's begin. So 2 raised to the power n is a common factor, okay, and the exponent of 2x is a common factor also. Okay, so I open a bracket. So in this case, 2 raised to the power n is out, exponent of 2s is out. So I am, yes, I'm left with just s cube. I'm left with s cube. So in this case, of course, okay, 2 raised to the power n is out, exponent of 2s is out. So I'm left with n 3s squared. Now I have, remember, I have 2 raised to the power minus 1. Already 2 raised to the power n is out. So there's going to be 2 raised to the power minus 1. Then 2 raised to the power minus 1. Okay. All right. Then I proceed. Let me start from here. Plus, let's go to this. Now, for me to work on this one right here, okay, I need to, as a matter of fact, divide this 6. This is 6 right here, right? 2 factorial is, of course, you know that it's 2 times 1. So 6 divided by 2, that's 3, okay? So I'm going to have 3, of course, 3x into bracket open, that is n, then n minus 1. Okay. Then, of course, I still have 2 raised to the power minus 2. Since 2 raised to the power n is outside, so I still need to evaluate 2 raised to the power of minus 2. Okay. I hope you're with me. Then the last but not the least, I work on this one. Okay, so then plus, let's work on this one. The last term there. Okay, so of course, 3 factorial is 3 times 2, which is 6. So 3 factorial will cancel definitely this 6 right here. So 2 raised to the power n is already outside. So what I will have left is n into n minus 1, all right, into n minus 2, all right, okay. Then of course I'm left with 2 raised to the power minus 2 dot 2 raised to the power of minus 3, please pardon me, 2 raised to the power minus 3. Since 2 raised to the power n is outside, then of course exponent 2x is already outside, so then I can now close the bracket. Okay, so that is exactly the derivative of that function. Okay, even though it's long, at least this actually build a foundation to the understanding of how to find the end derivative of a function, and it will help you in solving the ODE using Leibniz-Maclaurin series. Okay, so I hope this is well understood. We are going to look at more in the next video. So see you in the next video. Thank you very much.